Hello, this is Magnus speaking. In this video I will explain the development process of the control system software for a waterborne floor heating system. The system consists of a pump that circulates hot water through the floors and back to the boiler to heat it again. A mixing valve uses the cold water from the return pipe and the hot water from the boiler to adjust the temperature of the water going out through the floors. A series of other valves adjust the flow of the mixed water to individual rooms, giving some regulation of temperature to each room. As of now, the mixing valve is manual, and the pump turns off when the return pipe is warm enough to exceed the set point of the bimetal-based switch. The control software was developed using the unified process, and the first step of designing an application is the elaboration phase. Here the requirements are established and the framework for the application is built. This system will consist of a user interface, a data layer, and the logical layer, or the controller. The main part of the application is the logical layer, as this will run 24/7 to maintain the desired temperature. When these three parts are implemented and communicating, the next phase can begin, the construction phase. This system was found to have 5 use cases. It has to control the pump, control the outflow temperature, and control the individual valves that open and closes the loops going to each individual room. The more underlying use cases are the handling of data and error messages. The first and most important use case was selected to be the control of the mixer valve, as it controls the source of heat for the floors. With an even temperature coming from the outflow, the overall evenness of the system would hopefully improve. To obtain control of this temperature, the system would first have to check if the pump is running, as it is unnecessary to control the temperature without flow. Next, it needs to grab the configuration for the controller, including the desired set point. The temperature can then be collected before the controller can do its thing. I opted for a PID controller because it is easy to implement and tune. After the PID controller is finished calculating, the new position is sent to the valve. Finally, the valve position and the temperature reading are stored in the database. These steps will loop continuously with a fixed sampling rate. The initial sampling rate is set to 5 seconds, but the user will be able to change this if wanted. When testing the application after implementation, a simple simulator was made instead of connecting to the physical devices. This is because the .NET Core framework does not support serial communication, which was planned to be used as the interface between the server and the analog sensors and actuators. After giving the simulator similar behavior as the system, the controller algorithm was given a go. The results of the simulation were saved to a .csv file instead of a database, as that is not constructed yet. As you can see from this graph, the controller works well under ideal circumstances and should work fine with the real components. A new development platform or communication protocol will have to be selected before the final implementation. Going forward, the next step is to select another use case to construct. Controlling the pump will be this next step in the construction phase, as these two use cases combined will give software full control of the heat source. After that, a user interface must be made before the loops can be controlled, as the set point for each room must be set before the controller will know what to do. With the user interface, the error handler can also be implemented. That's it for now. I hope I'll be able to work on this project until it's completed. Thanks for watching and stay safe.